Good afternoon, everyone. Welcome to our episode again of Space Careers Talk. And today, I'm very happy to welcome with us um, Dr. Narayan Prasad. And we look forward to hearing from him today. Dr. Narayan Prasad is Chief Operations Officer at SAT Search, chiefly responsible for helping buyers find the right products and services for their mission or service. He also serves as a partner to Space Park Kerala, a Government of Kerala initiative to develop a dedicated space economy hub in India. He holds a PhD in supply chain management from the University of Erlangen-Nuremberg. He previously served as an associate research fellow at the European Space Policy Institute, where he contributed to enhancing cooperation between Europe and India in space. He has authored over 75 articles in various national and international publications and was educated in India, Germany, Sweden, and France. He is also an elected member of the International Institute of Space Law, awardee of Emerging Space Leaders by the International Astronautical Federation, and host of the New Space India podcast. So I'm very happy to welcome you here today. And with me is Mr. Arjun Gulia, who will also be supporting this session and bringing the questions from the students. So looks like you have a very widely spread educational background. And Dr. Prasad, you will also be telling us about some of the things that are very new to students, like space policy or space law. And we would be we are very excited to hear from you today about how you got started in this journey, in your personal journey in, in space sciences, what got you interested, and please tell us about what kind of work SatSure does and what kind of work you do. So over to you.
Okay, so thank you very much. I hope that you can see my presentation now.
Yeah, we can see it.
Right. So I'm going to turn this into full screen. Hold on a minute. Right. So thank you again for this particular opportunity. It's always great to address young people and you know be amongst them as they are the future for us. So I'm going to talk a little bit about how I started my career in the space sector as a young person, and have been doing space-related stuff for more than a decade now, actually. And in fact, I come from a normal, any middle-class Indian family, parents, both of them working, and going to a small town school again, almost. And as usual with many of the audience, I suppose, that you have today listening in here. So there's nothing special, I would say, than in terms of what is the background that I grew up with, or with the others, or so on. So it's more or less just the same background that any of your audience has today, in that fashion. But it's only that over time, if you can kind of stick to whatever you believe in, and if you have a certain direction that you can go in, you can do certain things. So I'm going to show you a few things about how I began my journey, and then talk about what are the things that I'm doing now, and hopefully something that you can take from all of this. So in fact, what I did is, when I started to um, begin about thinking about working with other friends of mine, I started actually designing and building these small drones. So this was a huge community up in Bangalore 15 years ago, when people started importing a lot of these kinds of styrofoam, a lot of the DC brushless motors, a lot of these things. And there was a tremendous amount of interest in aero design. And what we did in the university, or in the college that I was studying in, is a few friends of us, we pulled in small amounts of money, and we started designing and building these gliders. And of course, I think even today such activity may not be integrated into grades or subjects and others in India. I'm not sure how well it is integrated as of today, but all of this was extra work beyond the academic work that we guys used to do. This was after university school hours, after college hours. A bunch of friends designing all of this, building stuff overnight, crashing it in the morning, learning from something from there, going back again, building it better, crashing it again. So we did that for almost 2 or 3 years until we really came up with some designs that were really, really good, and really, really elegant. So what that led to is that we actually went to Bombay, to IIT Bombay, for a particular competition that they used to run on aero design. And it was our first attempt there of going there, and there were like 80 teams or so on. And we won a prize at that competition. I think we won the second or third prize. Now, it was a while back, more than 10 years ago. And so that gave us encouragement, saying that if we are to do like this, without any support from many other people around, and no real backing of anybody, we actually did then think about going to the US, actually, to participate in a NASA sponsored competition called the Aero Design event in Atlanta, right? And that's when we started putting in a lot more effort into all of this, and we tried to get our college to back us, our parents to back us, our industry to back us, and many other things. So it was a very organic growth, because we took 2 years to building all of this, and then suddenly we had interest, from support from university, from other people, and so on. So that's when we really designed all of these things, and it led me to step out of India for the first time to participate in this particular competition. And the final drone that you see here is actually from the final test. That these were from India, but finally we flew this particular model in the US, and we got a systems engineering award from NASA for flying all of this. And it was something that was really got me started into aerospace and aero design and everything else. So it was purely, starting from putting a few thousand rupees shared between a few friends, to then spending, getting sponsors and getting people to back us for a few lakh rupees to go to the US and fly all of this and come back to India, right? So we were the first team from India to get any kind of mention or any kind of award at that particular competition from Asia, actually. So we were really, really proud of what we would had achieved at that point of time. But today, you see, I'm sure that many of you own these kinds of drones at home today, given 10 years of change that has happened. And a lot of you might be flying this as pilots and so on. But all of this, 12, 13 years ago for us was extremely, extremely new. And we had to learn a lot of the things around by ourselves, and build a lot of these things and know how it works. And that was, I think, one of the great things that we did, is to work or do things hands on, and get our hands dirty in all of these things. I had memories of me sleeping on my computer with the keyboard patch on my cheeks many times. In fact, working very late into the night. I enjoyed working with my friends quite a lot. So that is how I began, and I ended up getting a mechanical engineering degree in India, in Bangalore. And then it took me a while. It took me a year to figure out what I want to do next. And one of the things that I did during my time is to work on a satellite structure in my bachelor days, right? So that led me to applying to many parts of the world to study abroad. And again, there were a lot of constraints, because if you want to study in places like US or so on, so you need to typically have a lot of money to go there, unless you have a scholarship, which in the field of aerospace is very difficult to get. And so I wanted to get into a program that can give us scholarship and would allow me to study for free eventually. And I had no risk for me to go out, and I did not have to borrow money from anyone at any given point of time, at that point of time. So I applied to several of the European universities which had many scholarships in there. And in fact, it took me a year to apply to all of this because in my university we did not have any advice from anyone that this is the path you can take to go study abroad, or this is what you need to do to go study abroad, or all of that kind of advice nobody gave us. So after I graduated, I was kind of lost for almost a year trying to figure out what I want to do next and so on. So but then I took some time to getting to know about what is the career path that you can choose if you want to study aerospace engineering, especially space and so on. So I applied to a program, and I applied to 20 different programs actually in different parts of Europe, and I got into 20 of them. And one of them was this program called the Space Master. It's a very attractive program because you spent 6 months in every different European country over 2 years. So, and then you could get a very broad exposure to space systems design and space systems engineering. And this was actually from 2010, this particular picture here. So 10 years now passed with this. And this was my class in Germany when I studied back in 2010, where we had 45 people from 26 different countries coming together to study space systems engineering. And this is how, like, I really got into the topic of space systems design and so on. So it was fascinating experience because I spent 6 months here studying about CubeSats, small satellites, CanSats, things like that. And then after 6 months in this particular program, you had to move or switch to other countries. So after spending 6 months in Germany, I spent like 6 months in Sweden. And this was again a very beautiful experience because I don't know if many of you recognize this particular light. It's the Aurora Borealis, or what people popularly call as Northern Lights. And in fact, when I was there in Sweden, it was the winter of 2011, and our job was to study these auroras. So every day, our job was to like use an all sky camera, all night sky camera, take pictures of these, study different patterns, study the structure. A lot of these things, a lot of the times that we spent were about space science and space physics studies there. And I was very lucky because that was one of the years of peak sunspot activity, and I could see out of my window every single night these auroras for 3 or 4 months continuously there. So I was extremely lucky to witness all of this. Coming from Bangalore, when where the temperatures are between 25 and 35 degrees, the least temperatures that I faced in this particular town was about minus 40, minus 45 degrees. So it was a very big variation of about 60, 70 degrees from where I typically come from in Bangalore. And so it was an experience on its own because you need to know how to survive the winter. You need to know how to dress. You need to know how to get out. You need to know how to survive. Otherwise, you can be dead in 15 or 20 minutes given the temperature that is out there in these places. And these are very deserted places. And if you go out 5 or 10 minutes, you're lost in the snow. Nobody can see you on the other side because there's piles of snow everywhere. And there's only a certain roads that are available to you. And there was this huge antenna there that we used to work on the data from all of these antennas. This is I think, a 42-meter dish that is out there. So it was an exciting time for all of us who studied all of this. And in fact, we also studied some data from the Chandrayaan mission, I think, at that point of time, because 2008 was the Chandrayaan mission. And the institute that we studied in, or the Swedish Institute of Space Physics, had actually flown a particular payload on the Chandrayaan mission. And we had some of the data from that where we could access that as well. So it was a very exciting hands-on kind of, again, time with especially space science stuff. So post that, I actually ended up going to France. So you see the French flag here. Was actually funded by the French government to study in France as well. So the French embassy in India has the scholarship. I think they still do have the scholarship. If any of you growing up want to apply to it, to go study in France. And I was one of the recipients of this particular scholarship, and this is one of the former heads of the European Space Agency, and we attended the International Space Station Symposium in 2012 in Germany, and it was a fascinating experience to be among all the astronauts who were flying to the ISS in person. And this was a meeting of all the heads of the different space agencies who were involved in the ISS program, a lot of the astronauts and so on. So all of these were my classmates who I studied with and so on. But I spent 6 months in France learning about the French space program, talking to a lot of people in the astronomy kind of program, especially in instrumentation design for astronomy, and how do you do like specific instrumentation design for atmospheric studies, or interplanetary studies or other planetary studies and so on. So it was a broad mix of experiences of being there and learning a lot of this. A lot of also we also did things like image processing and things like that, projects around all of that. So it's a very interesting period, and also this gave us a very good insight into how three different countries worked in their own space programs, because we had spent time in Germany and then Sweden and France. So it gave us and coming from Bangalore in India, I knew how ISRO works. So it over a course of like 2 years, I knew like how four different countries do space in four different ways, and that could give me a very nice connection to what it is and how it was and so on. So in fact, post that, what I did is actually I ended up doing some research as a part of my thesis for my master degree in the DLR, which is the German Space Agency in Bremen, the city of Bremen. And the model here that you see is, I don't know if many of you recognize it, but it's the V2, which was designed during the World War II as one of the earliest rockets to reach the upper bounds of the outer space, and 40,000 of them, I think, were tried to be built here. And in fact, this was the first ever test stand of the V2 in Germany. So unfortunately, this is an island in Germany, and civilians are not allowed on this island because during the war, this island was bombed to such a large extent that they still haven't taken out all the unexploded bombs on this particular island in Germany. This was where these V2 missiles were built. So the Allied soldiers, the Allied efforts, they bombed this place. And so only to a certain extent, civilians are allowed here into the museum. But if you want to go to this test stand, for example, it's only allowed to selectively to certain people. And since I was at the German Space Agency, I could get some special permissions to take a team there to visit that place. And in fact, you have to sign a declaration saying if there's any unexploded bombs that explode during the time that you are there, that the insurance contracts will not apply to you. So there's an element of risk of visiting the place, but it was a historical place to visit. Also very sad because all the technology that they built were aimed at attacking other people and destroying other cities, and not really to be productive as such, right? So it was a sad moment, and at that, and noting that, but it's a moment of history that you see there. And today there's nothing there, except this particular place. So there, everything's just a forest. You can't believe that they were 70 years ago or 80 years ago building these rockets that would be launched against French cities, British cities, against London and other places, that they were launching these things out of those places. And today you go there, it's bombed out so much and it's destroyed so much that except these forests, you have nothing there. You can't even recognize it, that they were building these whole things there, right? So some of you might have read some of this history, but I do encourage you studying some of this history, because it really gives you a great perspective as to how space flight and space has evolved over the last 50, 60 years, right? So with all of these kinds of experiences that I had back in Europe, I actually ended up coming back to India in 2012. And the goal was to start my own company in India, and to be an entrepreneur in the area of space technology. And and that brought me back to India. Uh, so this was a really great moment for us because this is my friend and colleague Sanjay, who studied with me as well, and this is Abhishek, who's one of our co-founders there as well. So we started a company called Dhruva Space. It still exists in Bangalore, and any of you who want to apply for internships or maybe jobs can contact them as well. They're based in Hyderabad today, but we started a company in 2012. Many of you might know Team Indus very prominently. We were, I think, a company that was born after Team Indus, but one of the early companies that were born beyond before many of them that you might know, including Agnikul, Skyroot, and others, right? So we had an opportunity to present ourselves to Dr. Kalam at his house in Delhi back then, and we wanted to build these small satellites in India, and that was a natural progression that I saw for myself as well, having studied a lot of these things. And we, in fact, tried to build this, and we imagined that if we could build all of this out of India, we could offer this to the international markets at 3 or 4 times lesser price than what American and European companies would offer to the international market, right? So that was kind of the goal, that we thought that we could actually sell a lot of the hardware that we would build to the international markets, taking advantage of the lower operating costs, lower manpower costs in India, to do what ISRO, for example, is doing in launching some of these satellites for the other countries at lower costs, and we could do that for a lot of this, right? So that is how I began kind of my entrepreneurial career. I had no experience in entrepreneurship. My parents, as I said, working class people, so they don't have any links to starting a business or starting a startup or anything like that. So everything was almost a first time experience, and just trying to get things done as things go for a lot of us. And maybe that's going to be like how a lot of you might also progress in your own careers, having to do stuff yourself for the first time as such. So this brought me into a lot more opportunities that I could imagine in all of this. One of the big frustrations for us at that particular point of time was that there's no real support from anyone in the system to help companies like us to grow as such. You see, like many companies, including big companies like SpaceX or so on, they get a lot of support from NASA, from US government, and even here in Europe, you get a lot of support from the European government and so on. So at this point of time, there was not much support that we could get from ISRO or whoever it is that who could help space companies. And that was a big part of the frustration that I had in my days as well there. So I actually stuck around in India for 5 years. So from 2015, 2012 to like 2016, 17, I tried to kick off, see if the company could progress. But I myself was a little bit more tired of not seeing progress happen and waiting for a lot of things. And there was also not many people who were interested in investing in space, as you would see today at that point of time. People would think that's a too risky area, or there was not many people who actually were interested in getting into areas like aerospace to invest a lot of money. So we had all of these troubles that today companies are able to solve, because there's a lot more interest and a lot more people investing in all of this, right? So that led me to trying to go back abroad and trying to kick off a new venture abroad. So it actually took me to the US, and this is a picture from the SpaceX factory in LA, and we had a chance to visit them for 1 day, where we talked about to their business team. We had a tour of their entire factory, and this is one of the rockets that were flown back actually, which is standing outside of their office there for you to see as well. So it was a very memorable moment for us, having gotten there and to interact with their teams and to look at all of this hardware being developed. It's a very rare occurrence, because it's very difficult to get inside unless you're invited to go and visit such a place. On top of it, me being a person from India, it's still very difficult to get access to any of this, because most of the American companies are very secretive about them, and most of them allow only American citizens to visit and to interact with a lot of the engineers and so on. So it was a very rare moment in time with all of this, but it gave me a sense of what I want to do with my next venture, and how I want to continue in all of this. So I was thinking that given my experiences with all of the stuff that is out there, that I wanted to start something new. And I did not have, as I said, again, a lot of backing and so on. So I actually started doing a PhD in Europe, because I had my master's already, and I thought a fun way of doing something is to get a PhD going, and at the same time using my free time during the PhD to build a company again. So I actually ended up doing a PhD in supply chain management. I was funded by the German government to pursue this research, and for 3 years. And in all my free time, I tried to build up my company ideas and try to build the product. And at the same time, I was advancing my research. And eventually, over 3 years of time, I managed to graduate with my PhD. And at the same time, our company started to get more customers, and we had enough money in the bank to work full time, and also to start employ people newly into our company. So we started incubating our company, and we had the support of the European Space Agency to kick off our company in the Netherlands. And that's how I started my entrepreneurial venture again, with a company called Satsa. So this is my current company. And what we do is, you can look it up. We have a website, and the goal is quite simple. I always asked a lot of my friends and colleagues here in Europe or US, saying, tell me one supplier who you know in India who supplies space related hardware. And normally they would say, I have no clue other than ISRO, who else is around. And that's a problem that we thought we can address, where we can allow people to easily find stuff. It's like building an Amazon for space, essentially, where you can go on one place and find everything that you can. And then you could build something. So this is my company as of today. So this is a brief introduction about myself, and I want to take some time to talk to you guys about how you could be involved in space technology as a hobby, and then maybe more professionally. So space tech as a hobby is a great way of getting into space, and that could be one way of getting to know if this is something for you and something that you could do professionally. And there's many ways to do it, at starting from very low cost means to trying different things. So I don't know if many of you know this particular thing, but there are many of the models for rockets, and to learn more about rockets, there are several paper models that are available. So these paper models are available on the internet for free. So in fact, for example, here's a particular paper model of the PSLV, actually. So I used to print these out and take to certain small schools, and in and around my area where I live in Bangalore, to tell kids how these rockets work, what are the different parts, why are the different parts like this, or and so on. So it may look very small, but I think it gives you a very low cost approach to understanding why rockets are built in certain ways, and what are the parts that are going into this. And just a printout that's worth 1 or 2 rupees is good enough to explain this for 1 hour, in that sense, to really know about an introduction into rocketry and so on. So I do encourage you guys to check out these paper rocket models. These are available for almost all the different rockets in the world, and they are available for free. These are all scaled models. In fact, you can print them out in cardboard and make a nice cardboard piece out of it and gift it to somebody as well, if you're interested. One of our friends, I got to know that from Mila, that he also talked to you guys. He created this initiative called Rocketeers, which involved building model rockets in India. India, unfortunately, does not have such a huge model rocket ecosystem. But then, this is heartening to see companies like this come up to build these model rockets. And today, model rockets are a great way of getting involved to know about propellants, or how rockets are designed, or trajectories, and how do you design for center of gravity, and many, many, many other parts of propulsion related aspects you can get to know. So I do encourage, getting checking out things like Rocketeers, where they are helping a lot of the young people to understand model rockets and so on. Again, this was something that was not in India maybe even 5 years ago, but today, is available in a country like India to understand and so on. So it's very exciting to see people addressing gaps, that especially for young people to understand or do hands-on stuff, especially with rocketry, because it's not very cheap, of course, to do anything in space, and especially in model rocketry. And if you want to buy some of this kind of equipment outside of India, it can cost several thousand rupees to import all of this. And there's a lot of hassle into importing as well, and also testing these out there. But I can see that these people have really, like, trained all of this, and have today made this accessible to the community in India. So I do think that this is a great exercise for you guys to, be involved in model rockets if you are, and to see how you can get involved. So Rocketeers has a particular, I think, website where you can have a look, and so on. So, and this is also an approach to a low cost, approach to space, and not just for young, schools that are in cities, but also in villages and smaller towns and so on. So it's very exciting to see that people can get into rocketry at a very early young age, and to learn about all of this. So this, for me, I think, is a very interesting development. So they do have a website where you can go check out some of their stuff, and you can see some of these model rockets, and I encourage you to check them out. I don't know if many people among you know about ham radio or amateur radio. Amateur radio has been around for more than 100 years, I guess, in that sense. But there's specific amateur radio communities also for satellites. So some of you who are interested in electronics, or radio frequency, and things like that, you or antennas or communication, for example, you might have used walkie talkies when you're kids or so on. So amateur radio allows you to build and design stuff by your hands, very low cost. You can build all of these by purely having some metal structures wired together to receive a lot of the signals from space, actually. So it's a very cool hobby to get involved in. In fact, I was involved in this by having to fly balloons and to track those balloons from the Indian Institute of Astrophysics campus in Bangalore, and we were doing a lot of the ballooning missions up in India. And that's how, we were trying to do all of this, right? So this is something that was very interesting as such. And you could get into this as a huge community. You can apply to get a ham license in India to be a licensed operator. It doesn't take much. I think the fees is like 100 or 200 rupees to apply for an exam, which you can write and clear and get a ham license. And then you can be involved in talking to people from different parts of the world. You can build antennas that can communicate with satellites. You can build your own ground stations that can talk to other satellites from other places, and so on. So there's a lot of potential for you to also be involved in such a exercise to get your hands on into all of this. So um, many of you might have also tried this particular thing. If some of you are interested in photography, especially with the Instagram generation of kids out there who are very interested in photography, there's also a stream of photography called astrophotography, where you can go to places which have not much light pollution. I imagine that Delhi and Bangalore and Bombay and others may not be the best places to do all of this, because they have a lot of light pollution. You might not get such great pictures from all of this. But in this particular video, for example, it's, for example, showing the rotation of the Earth, as the thing moves, and you can see the Milky Way around all of this and a lot of the things going on around here. So if some of you are really interested in photography, and you could also explore something like astrophotography, that is also extremely interesting for you to get into space as a hobby. And then you can also then get into astronomy and deeper aspects. Some of you might be interested in data analysis or playing around with data um, from astrophysical bodies and so on. So there's a lot of potentially open source stuff that you can do here as well. Here's a tool called Astrometrica, where basically they have a lot of data from different stars and so on. So you can play around with this. It's an open source tool you can download for free, use it, and then see how you could get involved in all of this. So if you are somebody who wants to analyze a lot of the things that are out there and wants to do it by having something open source, this is something for you. If some of you are gamers, some of you like playing games on computers and want to do something space related, I would suggest that you check out the Kerbal Space Program. It's a very cool game. I've been playing it as well. That's very interesting. In fact, you can build your own stuff. You can simulate a lot of the missions. You can get to know what is needed to have rockets work. And you can build a lot of the architectures. You can even put satellites in there. You can see what happens. And in fact, it's related very closely to the actual physics and the actual parameters that happen in actual space flight. So the modeling of this and the design of this allows you to actually really simulate a lot of the real world happenings out there. And you can design and play around, and this is a great way of learning a lot about what parameters are involved in building missions, and how do you get involved in all of them, and how this could how you could learn more about many mission design aspects out there. So if you are looking at using computer simulation games to learn about space, I do encourage you to check out this particular thing. There's a huge community also now building up within India of people who are KSP fans and KSP players. There's a fair number of people out there who can help you even within India to do all of this. In fact, a lot of them have even designed PSLV, GSLV, or Mangalyaan or Chandrayaan kind of missions as well in this, and they have simulated a lot of this. So I do encourage you to check this out if you want to target some of this and so on. So the next thing that I really wanted to speak before we get into like the Q&A session is about how can you get involved more professionally, right? Right now you may be in schools or colleges or wherever, and then what you need to know is that space, although there's a lot of fan following and a lot of fan base to a lot of the space science related efforts, satellites are like any other tools, and they enable problem solving. This is, I think, a key takeaway for a lot of you. There's Space has a lot of kind of celebration and celebrity kind of status in general public, I think. But ultimately, if you want to be involved professionally, you have to know what is your core strength, and what are you looking at. And the best way to do that is actually looking at what problems you can get involved in solving that can use space and satellites. So what I encourage you to do is to think about how you can either build satellites or use satellites to solve a lot of the problems around you. So here are some examples. So I know that many of you are from Delhi and other places in the world, and this is one of the biggest topics in India today, where air pollution is a huge topic in India, right? So satellites can provide a lot of the parameters. In fact, today people are mapping carbon emissions, they're mapping methane, they're mapping a lot of the things from space. And you could design sensors that can map local pollution parameters, or you could build apps that people can use to look at air pollution and monitor air pollution, and you could help governments to see what are the sources and so on. All of this uses either you building sensors that can fly in space, or apps that involve using satellite data itself, right? So farmers is a big issue. There's a lot of things happening with farmers in India today, and I don't know if many of you know that a lot of the applications of satellite data is in agriculture, where people can look at which crop is being grown, and how healthy is the crop, how which what is the forecast, how does weather affect it, how climate change is affecting it. So if any of you want to get involved in, have a passion for farmers, have a passion for agriculture, and want to use this technology, I encourage you to check out a lot of the data that is open source and available for satellite data for agriculture, and look at how you could use that to help farmers at the end. There are other applications, for example, fishing. There's a couple of companies in India today, for example, that are targeting fishermen. So they can get easily lost in different waters. They can be affected by weather. They may be captured by other countries because they don't know the exact location on the ocean. So there's a lot of those kinds of problems that fishermen face. And again, using GPS, using Navik, using communication satellites, you can help them by providing them devices, by helping them use smartphone apps to do a lot of the monitoring and to ensure their safety among weather, among location, and every other thing. You might have seen, Starlink or Elon Musk's satellites, or Jeff Bezos satellites that are up and coming, and even Bharti Airtel. Airtel has also bought recently a satellite company, and they're planning to provide access to rural internet in India using satellites. This is going to be a very exciting field because broadband internet is constrained to a lot of the first tier, second tier cities in India, and rural parts still have trouble getting, maybe high speed broadband connections. And this can be an exciting area again for people to get involved in taking internet to rural parts of India, to villages, and making sure that people there are also connected to the internet, and to pass on the benefits of all of this. So a lot of you are watching this stuff and on YouTube, and again, the location and the connection that you have to watch this live matters a lot. And so if you can provide satellite based internet to those places which are remote and rural in India, those people also can get onto the internet and do all the things that you guys are doing, for example. One of the, again, the big issues in India, for example, is water quality, for example. Again, this is something that space and satellites can be of big use, because a lot of the pH sensors, a lot of the surface level parameters, sea surface temperatures, a lot of the sensors that can be basically put into waters to take readings, a lot of the buoys that are out in the ocean, all of them can be linked to satellites and space. And you could get a lot of the data that you could use to pinpoint water quality, poor water quality, and to improve a lot of it and flag a lot of this to the government and other policymakers. So I encourage you to look at how you can tackle some of the challenges that are out there, and you can provide some solutions, thinking these are some of the capabilities in space that can be used to solve some of these kinds of problems. I don't know if many of you have been following, but forest fires is a big issue that's up and coming due to climate change. It's actually very hard to detect a forest fire until it's become very big. So one of the things that people are trying to solve in all around the world, in places like Australia or California or Europe or wherever it is to look at how they can analyze or how they can detect a particular forest fire when it's quite small, so that they can put it out quite quickly before it takes away a large parts of forests down with it. So this is again a space-based application that people are thinking about, where they can build very sensitive cameras that can detect very small forest fires, so that they can immediately act on the ground to put out those fires, and not have tons and tons of acres, kilometers of acres of forest destroyed before they can take control of it. The good thing for all of you out there is that unlike 10 years ago or 15 years ago, there's a lot of new companies that are up and coming, and a lot of new investment that they have raised for you to participate as students, as interns, as employees, and even perhaps you can start your own companies at some point of time. So I encourage you to follow a lot of these young companies, because they will have a lot of opportunities for all of you in the coming days and years. And perhaps you could be one of these companies here on this table in the next years as well. uh, so I do encourage you to check out all of them and keep their progress under check. uh, for a lot of you who want to learn more about space in India and space related issues, and to want to get involved with the community in space in India, I definitely encourage you to check out the New Space India podcast. This is a podcast that I run with guests from all over India and even abroad, who talk about many issues related to space, that even a high school student can understand without much. We don't go into much of the technicalities, but we try to give you a perspective on what are all the issues that are happening, and what could you take away from all of this from different conversations, or how the space program has been in India built up for the last 50, 60 years, and what are the challenges for the future. So I do encourage you to check out this particular podcast. Finally, if some of you are interested in keeping in touch, I do encourage you to join our Discord community. So we have a Discord community where most of the young people who are involved in space are on the community, more than 500 of them, who are doing something or the other with space and are interested. So if you are interested in getting involved, feel free to join us on the Discord community. And if you have any particular questions or queries, or want to get in touch, here's my email and my Twitter account here. So feel free to do that. So I thank both Dr. Meela and Arjun for giving me this great opportunity to present my perspective, and I do hope that this was worth your while listening to this, and I'm happy to answer any particular questions that you might have.
So thank you, Dr. Prasad. That was really great because you introduced so many different facets of how students can get involved. And you can probably see on YouTube that there are so many questions just flitting by. Uh, so one thing I would like to share with you students is we have also, you pointed out the software, and we ourselves conduct asteroid search campaign once a year or twice a year. So students, you're very welcome to get involved with us in the campaign. Uh, so, uh, Arjun, would you like to bring some of the questions? So, I
Yeah.
would like to say, Dr. Prasad, that many of them are asking about drones and where to learn about it. And of course, Rocketeers. We ourselves have given you the link, uh, but I mean, we've introduced you to Divyanshu, but we'll give you the link again. So, Arjun, yeah, go ahead and bring some of the
Yeah.
questions to him.
Yeah, sure. So here, I mean, initially, a lot of questions were about the drones itself. So most of the students were asking about, sir, how can I make the drone? What is required for me to make the drone? Is it wireless, or has a wire? And what are the softwares we use? So can you just put a small light that, okay, so to make drones, and so what exactly are the requirement, and how you can basically get started also?
Right. So there are a lot of very simple handbooks of aero design. Not most often, I think the problem is that a lot of the students might only go and buy drones by themselves. I don't think that is very useful, because you don't learn the principles of aerodynamics or air design if you just go buy a drone. Because today, there's so many Chinese companies that have made drones so cheap for you to just go buy them, and they have integrated radios and everything else. So you don't learn anything except flying drones if you buy them off the shelf. The better thing to do is to look at specific aero design handbooks, aero design communities. There's a lot of them. In fact, even on YouTube, we might have a lot of the open lessons that are out there to start designing drones and how do you do that. So there's a lot of open source stuff that is out there in aero design. So the initial bit will be about designing how much wingspan you have, how much is the payload capacity you want to carry, what is the radio controller that you want to use. All of these are different elements that are out there. So I encourage you to firstly get involved in, understanding the design principles by understanding, what is the flow, for example, depending on the kind of the wingspan that you want to have, or the cross section of the the wing itself. There's many principles in aerodynamics that you have to learn before you go on to all of that. So there's a lot of open source tools that are out there that can give you a lot of this, but the best is to study some of the aero design principles by studying aero design principles books related to that. That would be a good start, because you can even start with gliders. So what we did is that initially we did not want to spend money on having controllers or motors or things like that, because those are expensive hardware. You have to buy the motors, you have to buy the controllers, you have to buy the propellers, you have to buy radio equipment, all of that. It still is expensive to buy that. So you can still simply design something that doesn't have any electronics in it and can simply fly in the air like you would fly in a paper plane. If you design it well enough using thermocol, for example, it can still hold on to the to the air for quite a long time as gliders. So glider design has its own beauty, because you don't need any electronics in it, and you can simply still have those gliders fly by. And that's proof that your designs work, your wingspans works, your the kind of things that you're doing in manufacturing works. And there's a lot of intricacy in manufacturing them as well. You need to come up with jigs and tools and things like that to match the pattern of the wing. You have to know how to design all of this. So in fact, we were using a lot of the hot wires, because when you run a hot wire over a thermocol, you can get the shape of the thermocol you want, right? Because normally thermocols are just rectangular blocks and you have to cut them to get the exact shape you want. So we were having a lot of the jigs and fixtures that we built by ourselves by having the simple wire that we passed electricity through the wire to heat it up, and then we used to run that over a thermocol to get the exact wing design, and we put it on top. And then basically we had gliders. That's how we actually began, even before propellers. So that could be a great start actually to get into glider design. You get your gliders moving without any propellers or anything out there, and that gives you evidence that you have done a good job with the design itself. And then you can add propellers, you can add radio equipment. So it's a stepwise process, so that you don't get overwhelmed with everything at one go. And then you can go take that. And only thing is, I think most of them just need to have patience, because none of this will happen in 1 or 2 weeks. You have to have 6 months, 1 year kind of a time frame to get involved in all of this.
Right.
Yeah. Okay, thank you so much, sir. So with this, I have another question. So this is okay. So knowledge corner. So he's asking, sir, how many times can a reusable rocket be used? Because obviously corrosion will definitely be acting on the outer side of it. So there has to be a limit on it, right?
Yeah, so this is a very good question. In fact, this is something that people are testing now. They don't know. That's the answer that most people are trying to know, because you can keep reusing it, but the problem is that you cannot take a chance after a certain while, because the satellite that is going on a particular rocket costs tens and hundreds of millions. So even if you want to keep reusing, and it really depends on how comfortable is the person who's bought that rocket, is comfortable in flying on a reused vehicle, right? So imagine yourself flying in a 1950s aircraft from Delhi to whatever, Bombay or whatever, right? Would you do that, is the question, right, as a passenger? Or would you want to fly something that is 2020 built and is proven of everything else? The analogy is more or less the same. Some people may be saying, it's very cheap because the flight, we brought it at no cost, so the airline tickets is only like $100 against $1,000 that you have to pay for a new aircraft or something. But then the question is, are you safe enough in going to all of this? So then you might say, I would rather pay for something that is 2020 and not 1950. In that sense, that's the very same analogy to a lot of this. It's not the person who has built the rocket who decides if they are going to fly the satellite, if they're going to fly that rocket. It's the person who is buying the rocket, who's a satellite manufacturer who decides if I want to fly on a used rocket or not.
Yeah, yeah. Okay, that's a very good answer. Yeah. Okay, so with this, I go to the question of Arav Bhardwaj. He says, "Sir, from where and how do we control the satellites?"
Right. So all satellites have ground stations on the ground, which means they are basically antennas. You might have seen some of these antennas that are used for television networks, for example. There are similar antennas that control satellites. There are different bands in which satellites can be controlled, and it purely depends on the data rates. So some of you who might know something about radio communications, there are things like FM that about radio, right? So 98.4, 99.1, whatever, many, maybe it's too new for all the new generation to know about FM as well. But if none of you know, it's the same thing, that if you go above the frequencies, then you go up to 400, you start from 145 to then to 400 megahertz, and then you could go into the gigahertz scale. As you go up, the data rates keep increasing. So if there is, for example, there are satellites out there that are streaming live video from space today, and those are very heavy videos, so they use higher bandwidth. They use in the gigahertz range of transmitters that are using dishes on the ground, 3-4 meter kind of dishes on the ground, which receive all of that. But then generally it depends on how big is the data that you want to send. Some of you also might know Voyager, for example, that's been around for like 30-40 years now. And even that is being received on the ground. For that, you need still a large antenna and so on. So there are all of these antennas. They are, unfortunately, due to the curvature, I mean the earth, the polar satellites, if you have ground stations up in the north, in Norway or in Antarctica, you can communicate with them 15 times a day. But if you have a ground station in India, because the satellites only pass 3 or 4 times over India, if they are low earth orbiting satellites, you only get to talk to them 3 or 4 times a day instead of 15 or 16 in the poles, because most of the polar satellites, they go over the poles every 90 minutes. So they can talk to those stations in 15 times a day, unlike India, for example, where even if you have stations across India, maybe you can talk to them 3 or 4 times.
Yeah, yeah. Okay, thank you, sir. So what about the Starlink satellites? So what kind of bandwidth they use?
So I don't know exactly the frequencies that Starlink uses, but I was just watching a review of them. Uh, it looks like they are in the Ka band, or maybe, I guess so, but it's mostly it's something about like 10 gigahertz or so, I think, or for sure. So right now they are the difference between Starlink and the others is that latency time. So I don't think many of the young people here really know about old generation phones where you had to wait before the signal
S-
used to pass along before you could talk. But then that's related to latency, because as you go further away from the earth, you have to wait for the reflection to come back. So if you, for example, if you want to talk to the moon, if somebody is on the moon, there's always a delay, because you have to go that far distance and come back, and it takes time for the radio waves to go and come back. And so there's like a 2-second delay if you want to talk to
yes.
somebody on the moon, for example, right? And it's the same with communication satellites, because normally those communication satellites are in the 36,000 kilometer orbit, which means that it takes a while for the radio frequencies to hit them and come back. And so there's always a latency. If some of you are gamers,
Yes,
you're
yes.
playing games
That's what I
on
was going to get.
Steam and
Yeah.
so on, you can
Yeah.
see this latency. And if you
Yes.
want to play games like Counter-Strike, or all of these role play, or all of these first person shooter games, you'll see that after a certain latency, like maybe 50-60 milliseconds or so on, it's almost impossible to play them, because you're always getting shot or the other person. And that's the same with satellites, right? Because as you go further up, you have a delay in all of this, and so there's a longer time that servers have to accommodate for. So essentially, people who have fibers, they solve it by having lower latency times, and that's exactly what Starlink is trying to do. They're trying to bring the satellites from 36,000 kilometers to 1,200 kilometers or so, which is like a massive reduction in the height, which means that you can get latencies of like 10 20, 30 milliseconds, which would be like what you would get on a fiber on your home internet connection via the fiber line instead of the geostationary satellites.
Yes, yes. But in the same at the same time, it is going to affect us observational astronomers because it is obviously always going to hamper with the way we are looking at the stars.
Right.
Yeah. Okay. So
So,
so
so
with
I
this,
think we're getting pretty close to the end. So
okay. Yeah.
maybe a
Yeah.
last question, Arjun.
Yeah, sure. So, okay, so I have a lot of questions. So, ma'am, if it is, I have to choose the last, it's definitely tough for me. So, let me just ask you. Okay, so, okay, I have a good question from Abhinav Chamoli. He's asking, sir, you have to plan a combustion chamber for your propellant, plan your payload, recovery system, and etc. In order to make a rocket. So, when you make a rocket over there, so he's asking about that.
Ooh, it's a
That's
tough question.
yeah,
Yeah,
that's a lot of it, a lot of planning already in that.
yeah,
yeah. So the thing is, uh, the rockets themselves have extremely different subsystems out there. As you know, engine is in itself is a huge subject, and you might spend a lifetime just learning about engines and how different engines work in different ways. So, and there's the other control system part of it. There's the design of the rocket, the aerodynamics of it. So it's not something that I can address in a couple of minutes, unfortunately. But
yes,
I do encourage you to read a book by Gopal Raj. He is an Indian author. He's written a book on the how the PSLV was designed, and it's a fascinating book. It's out of print, unfortunately, but I can pass on the copy of the scanned copy of the book to you, and you guys can pass it on to all
Yeah,
of your
we can do that. Yeah.
students. And yeah,
yeah,
and that will
Yeah.
give you a lot of insight for sure.
yeah,
Yeah,
perfect.
so I think you gave a lot of different options for them to, uh, try out their hand at different things. Many of them seem to be interested in drones, and some of them seem to be interested in rocketry. We already introduced rocketeers, and just remind us, where are those paper models that you? Is it on the ISRO website? Because some people are asking about the paper models that they can download.
I'll send you the links as well for that. So
Okay, so that's great. I'll share some of the links with everyone.
right.
And yeah, and I think your story has been great because you've talked to them about entrepreneurship and about privatization, and because these are all young guys, and so ISRO has now opened up to privatization to a little extent. That will really help all these guys, all these students, try out different things and maybe have more of the confidence to embark on new ventures, which was very difficult at when you started. But of course, we all knew about Dhruva Space, and that was one of the uh, first companies to start that way. And to everybody else, I'll also say that Dr. Prasad also is very popular because of the New Space India podcast that he conducts, and he's one of the prime movers of a WhatsApp group that connects New Space India people all over India and also some abroad. So these are new methods of communication that you've been showing us. So with that, please give us any last words of inspiration. And also, some students ask who inspired you. So maybe you can answer both those questions.
Yeah,
Um, Unfortunately, I think nobody inspired me to that certain extent. I would think I was probably a lost soul, but only connected the dots as things came along. So I was just free to explore whatever I could explore on my own. And, I just did whatever I liked. And so far, it's worked out well for me in that sense. So I would say that. Just do whatever makes you have fun, and hopefully if you are having fun in whatever you're doing, then it doesn't feel like work. So that's mostly it. And then I guess for a lot of the young people, I think uh, things take time. Most people on the social media are expecting likes the next 10 seconds after you post something, or they want to post every 1 hour of something. But I think if you want to build a career in space, you need at least 10 years. So if you're really serious about aerospace engineering or a career in space, you cannot build it overnight. You would need at least 10 years of effort to getting anywhere. So if you are not somebody who is not willing to invest that kind of time, I would suggest you do something else. So it's very very hard to get into this sector. A lot of people, who I know in India always want to get into the sector, but they're not prepared to invest the time and the effort that it needs to achieve anything in there. So that's mostly it.
Yeah. So thank you again for joining us. And I think the participants really enjoyed your experiences. So thanks Arjun for bringing the questions and supporting the session. And with that, everyone, participants, thanks for joining us and goodbye.